Hello guys, my name is Bino, and in this video we'll be focusing on question 2 from the April 1st 2020 N4 mathematics question paper. Question 2.1, we are given the graph of y is equal to 2 cos x, and we are also given a shaded area from 0 to pi over 4 and a vertical strip. So we have delta x because of that vertical strip, and delta x, this was not given, but delta x is equivalent to dx. So question 2.1.1, we have to determine using integration the value of the shaded area in the graph. So we use the formula from the formula sheet. So where area is equals to the integral from a to b of y dx. We use that dx because of the shaded area, it's vertical, and the strip, the delta x strip, that delta x is equivalent to dx. The boundary of this shaded area is from 0 to pi over 4, so we substitute 0 for a and pi over 4 for b, and our graph is 2 cos x dx. We can write that 2 out of the integral because it's a constant. From here we integrate the cos x, so the integral of cos x is equal to sin x, and our area is from 0 to pi over 4. We substitute pi over 4 where there is x, and later we substitute 0 pi over 4 minus 2 sine of 0. So we substitute that pi over 4 first, and then we substitute that 0 later. So a will be equals to 2 sine of pi over 4 minus 2 sine 0, and this will be equals to the square root of 2, which is also equals to 1,414. So we are given pi, so our calculator has to be in radians and not degrees. Question 2.1.2, we have to calculate using differentiation the minimum and the maximum turning points of the graph. So we still have the graph of y is equals to 2 cos x, and to find the minimum and the maximum turning points, we have to, so we have 2 cos x. To find the minimum and the maximum turning points, we have to differentiate y over dx and equate it to 0. So dy over dx is equals to 2. The derivative of the cos x is equals to negative sin x. So we have to, so this will be equals to 2 negative 2 sin x. So we have to set this negative 2 sin x, and we equate it to 0. So we divide both sides by negative 2. That negative 2 will cancel out that negative 2, and sin x will be equals to 0 over negative 2, which is equals to 0. We have to make x the subject of the formula, so x is equals to arc sine of 0, and the arc sine of 0 is equals to 0. So we have x is equals to 0, and x is equals to 0 plus k multiplied by 180 degrees. We are using 180 degrees because this graph of y 2 cos x will change. So this is pi or 180 degrees. So we are using that k multiplied by 180 because that's where it's going to change. That's where it's going to turn and change its direction. So it was going up. So from after 180, it's going to go up. So our k will be equals to 1 multiplied by 180 degrees, and this will be equals to 180 degrees. And our graph ends there, so there is no need for us to substitute for k is equals to 2, 3, or 4. So we have x is equals to 180 degrees. So the first turning point was x is equals to 0, and the other turning point was x is equals to 180. So far we only have the values of x, we don't have the values of y. To determine the values of y, we have to substitute x. The first value will substitute x is equals to 0 in the original graph, not the derived graph. In that graph, let's substitute x to find the corresponding let's substitute the 0 to find the corresponding y value when x is equals to 0. So this will be 2 cos of 0, which is equals to 1. So, and that one multiplied by that 2 will be 2. So to find the corresponding y value when x is equals to 180 degrees, when x is equals to 180 degrees, or when x is equals to pi. So we can substitute pi there because pi is also equals to 180. So 2 cos of 180 degrees, this will be equals to 2 multiplied by negative 1, cos 180 is equals to 1 is equals to negative 1, or cos of pi is equals to negative 1. So this will be equals to negative 2. So when x is equals to 0, y is equals to 2, and when x is equals to 180 degrees or pi, then y is equals to negative 2. So these are our two coordinates of our turning points. Question 2.1.3, we have to distinguish using second derivative between the minimum and the maximum turning points of the graph. So we had y is equals to 2 cos x as our graph. So we have to distinguish between the minimum and the maximum turning points of the graph. So we have to state which one is minimum and which one is maximum. So we do that by the second derivative. So the first derivative was equals to 2. The derivative of that cos is negative sin x, and this was negative 2 sin x. So for the second derivative, d squared y over dx squared negative 2 multiplied by the derivative of the sin x is equals to cos x. So to determine whether the point is maximum or minimum, we substitute the x value. So we have the first point was 0 and 2, and the other one was 180 degrees or pi and negative 2. So to determine whether the value is maximum or minimum, we substitute the x value. So that x value and that x value is what we substitute. So we first substitute the 0, and this will be negative 2. So multiplied by cos of 0, which is 1, and this will be equals to negative 2. So since we have a negative value, so when we have a negative value, this means that this will be a local maximum. So we substitute that 180 degrees into that second derivative equation. So d squared y over dx squared is equals to negative 2 cos of 180 degrees, and this will be equals to negative 2 cos of 180 is equals to negative 1, and that negative 2 multiplied by that negative 1 will be positive 2. And since the d squared y over dx squared, so since this is positive, this will be local minimum. Question 2.2, we have to integrate the following in terms of x. We have the integral of 1 over x squared plus 3 over 2 sin 3x plus 3 times the square root of x minus 10 multiplied by 10 raised to the power x plus 1 over sec 2x minus 2 multiplied by x raised to the power 0 dx. So let's first try to simplify this integral so that it can be easier for us to integrate. So 1 over x squared we can express as x to the power negative 2 plus 3 over 2 sin 3x plus 3 times, so that the square root of x we can express it as x to the power 1 over 2 minus 10 multiplied by 10 raised to the power x, and we know that 1 over sec x is equals to cos x. So we can express that 1 over sec 2x as cos 2x minus 2x raised to the power 0 will be equals to 1, and that 1 multiplied by this negative 2 will be equals to negative 2 dx. From here we integrate the integral of x raised to the power negative 2 will be equals to x raised to the power negative 1 divided by the negative 1 plus 3 over 2. The integral of sine 3x is equal to negative cos 3x. According to the chain rule, we also have to divide by the integral of the 3x, the function of the function. So if we were differentiating, we were going to multiply by the derivative of the 3x. Now that we are integrating, we have to divide by the 3, which is the derivative of the 3x, plus 3 multiplied by the integral of x raised to the power 1 over 2 will be equal to x raised to the power 3 over 2 divided by 3 over 2. So if we were differentiating, we are going to multiply by it, but we are integrating, we are dividing, minus 10 multiplied by the integral of 10 raised to the power x. So if we had e raised to the power x, the derivative of this was going to be ln of e multiplied by e raised to the power x, but ln of e is equal to 1, so 1 multiplied by e to the power x will be equal to e to the power x. But we have y is equal to 10 raised to the power x. When we differentiate, we have to ln the 10 and multiply it by that 10 raised to the power x. Ln of 10 is not equal to 1, so we have to include it. Unlike ln e is not necessary for us to include it because it's equal to 1. So here we'll include ln of the base 10 multiplied by 10 raised to the power x plus the integral of cos 2x is equal to sine of 2x. According to the chain rule, we are going to differentiate the 2x and multiply it with the result, which was 2, but we are integrating, so we have to divide, minus the integral of 2x of negative 2 will be equal to negative 2x plus c. So let's try to simplify this. So this will be negative, so that x to the power negative 1, when it comes to the denominator, is going to change. The exponent is going to change sign from negative to positive 1. And that 3 will cancel out that 3. And that negative multiplied by that positive will be negative cos 3x over the 2 plus 3 multiplied by 3 over 2 x raised to the power 3 over 2. So when you simplify this, it will give you that minus 10 multiplied by ln of 10 multiplied by 10 raised to the power x plus sine 2x over 2 minus 2x plus c.